So before we get started, let's do a little prior knowledge check to make sure we remember how to graph a line. So to graph a line, we're going to have these in slope-intercept form. So we have y equals mx plus b, where your m is your slope and your b is your y-intercept, okay? So if you remember, your y-intercept is where it hits the y-axis. So on our y-axis, we're going to go down to -5, which is right here. And then we're going to use slope to get the rest of our points. So our slope is -1/2. So that means we're going to go down 1 and then to the right 2. Down 1, right 2, down 1, right 2. You can do that a few times. You can also go in the opposite direction. So we could have gone up 1 and then back 2. Okay. And then you want to use a ruler for these so that your line is accurate. And then you're going to draw a line through those points. Okay. We also have a couple of special lines. So we have y equals 3. So we're going to go to our y-axis and go to the 3. And then these are horizontal lines. Okay. So we're going to draw a line horizontally through that point. And then x equals -1 on our x-axis. We're going to go to -1. And then same idea. We're going to draw a vertical line through that one. So let's talk about a system of equation. Previously, when we're solving equations, we're usually just solving for one variable, but in a system of equations, we're going to have multiple equations so that we can solve for multiple variables. Okay, so we have multiple equations to solve for multiple variables. Okay. For now, we're going to focus on just 2 variables. We're looking at lines, but eventually we can get to 3 or 4 variables. Okay. So with our lines, we have 3 different types of solutions that we could have. We have one solution, which is the easiest one. This is where you just have 2 lines and, oops, you have 2 lines and they intersect at just one point. Okay, so right here is where they intersect. So your answer is going to be x comma y, so that point where they intersect. Okay, we also can have cases of no solution. No solution happens when these lines never intersect, which is another way of saying that these 2 lines are parallel. Okay, so parallel lines never intersect. If you ever see 2 lines that have the same slope, that means that they're parallel, right? As long as their y-intercept is different. And then we also have infinite solutions, which means that they're always touching, okay? So if they're always touching, that means that they're the same line. They just might look a little different in their form, which we'll see in a second. So the same line would literally be like one on top of the other, like that. Okay? I'm going to draw, hold on. I'm going to draw the other one so you can see it. Something like that. They would have the same slope and the same y-intercept. So let's get into an example. We want these lines to be in slope-intercept form just for easy graphing. Our first one is already in y equals mx plus b, but our second one's not. So we always want to first rewrite our equation or solve for y. So I'm going to add 3x to both sides. Okay. 3x and 2 are not like terms, so we just write them separately. 3x plus 2, and now we've got our slope and our y-intercept. And now we're going to graph these lines. So we've got -4 for the y-intercept on the first one, and then our slope is -3, which we can always put over 1. So we're going to go down 3 to the right 1, down 3 to the right 1, and then you can keep doing that. Up 3, left 1, up 3, left 1. Again, this is where a ruler is going to be really important. So I'm going to start here, and then you'll use a ruler for this part to graph your line. Okay, and then we're going to do the blue one. So this one starts at positive 2 and then goes up 3 to the right 1 because it's a positive 3 over 1. Up 3, right 1, and then down 3, back 1, and then that's where we should see that they had the same point right there. Okay, so using our ruler for you guys, we're going to do that. And the point where they intersect, so they intersected right here, that's going to be our answer. So our solution is going to be -1, -1. Okay, because my x was -1 and then my y was -1. That's it. All right, so let's try another one. This time, both of these equations are not in slope-intercept form. If you know how to graph with standard form, that's totally fine. But I'm just going to try to make it easier because most people are used to y equals mx plus b or slope-intercept form. Okay, so I'm going to move the x over. Again, those aren't like terms, so I'm just keeping it like this. And then we are going to divide by 2. And when we divide by 2, we have to divide everything by 2. So -4 divided by 2 is just -2. 8 divided by 2 is 4. Okay, let's do our other one. We're going to move our x's over. And then divide everything by 3. 6 divided by 3 is 2, and then that one is 4. And we can see right here, we ended up getting the same exact line, right? This one and this one are the same line. So we know before we even graph it, this is going to be infinite solutions, okay? Because when we graph it, we graph the same exact line. Let's go ahead and do that real quick. 1, 2, 3, 4. And then it's going to go down 2 over 1. And then we can graph our line. So we've got the same 2 lines. And to show that, you're just going to draw one over the other, or you could do like a dotted line. I'll show you what that looks like in a second. So you could do it like this, where you see both of them if you have different colors, or you could draw one line and then extend it out with dots to show that the other line is right underneath it, okay? Either way works. All right, so we've got another one that is in standard form, and we need to rewrite it, unless you're good with standard form, either way. So we've got 2y equals 3x plus 6. Divide by 2. 3x over 2 doesn't simplify, so we're just going to leave it as 3 over 2x. 6 divided by 2 is 3. Okay, then we're going to do the other one. 4y minus 16 is 6x. We're going to add our 16. And then divide both sides by 4. Okay, 6 over 4 simplifies to 3 over 2. And then 16 divided by 4 is 4. So in this one, again, before we even graph it, I have the same slope here, which means that these are going to be parallel lines because the intercepts are different, okay? So they're not exactly the same, but they are parallel, which means that this is going to be no solution. And I'll show you on the graph what that looks like. Okay, no solution. So, reason why, we have the first one that starts up at 3, and then it's going to go up 3 over 2, down 3 back 2, down 3 back 2. Okay, so there's our first line. And then we've got the second one, which starts at 4, right above it, with the same exact slope. Okay. So for that one, looks like that. Okay, so those two lines are right next to each other, parallel lines, but they're never going to touch, so no solution. All right, last one. We have 2y minus x equals 10. We're going to put it in the correct form. and then divide by 2. This is a 1x, so this is 1 over 2x plus 10 divided by 2 is 5. Okay, so 1, 2, 3, 4, 5. And then we're going up 1 over 2. So that looks like that. Okay, the other one is one of our special lines. That is x equals 2, so it just goes through x equals 2, and it's a vertical line. So our solution for this one is right here. And then that coordinate, solution, is 2, 1, 2, 3, 4, 5, 6. 2, 6, because that's where they intersect. And that's it. Okay, in this video, we reviewed how to graph lines, and then we learned how to find an intersection to solve a system by graphing, and how to determine if there is one infinite or no solutions to a system. Remember, one just means they intersect at one point, infinite means that they're the same line, and no solution means that they're parallel. Thanks for watching.